Last week we did this paper, October, November 2005, variant 42. Let me just go over with you the last part, the last question. This part explain how X-ray are used in computed tomography technique to produce a three-dimensional image of an internal structure. I checked your syllabus already. Your syllabus is clear lah. Is reduced from previously. Previously, a bit of calculation involved. There's no calculation involved. So structure is scanned in thin slices. Right? Whereas X-ray, you just do one exposure. That's all. So you go to the picture of the internal organ. Whereas this one, the structure is scanned in thin slices. Many scan of each section taken at different angle. You do it at different angle. And then one section ready, then go to the next section. Scanning repeated for all sections and data compiled to form a 3D image. So you need a computer. Basically, you're building a structure of the human body in a computer. And then you can view the whatever organ or tissue that you are interested in 3 dimension. Okay, so that's roughly the machine. Right? So person can be slide in and out. Then this one can be moved around. Right? This section at different angle. Okay, any comment? Refer to the note.
No.
Teach you a bit of it.
Okay.
Okay, comment. Okay, let's carry on with October, November 25, paper 44. Right? 43 is repeat of either paper 41 or 42 lah. So we won't go over it again. Right? You can read that yourself about binary stars if you are interested. State Newton's law of gravitation. Gravitational force.
The force,
Okay, go ahead.
and then inversely proportional to separation
Say again.
separation of masses.
Say
And then
again.
inversely proportional, the force is directly proportional to product
Yeah. Repeat
of
your
masses, and
answer.
force directly proportional to product of masses and inversely proportional to square of
Yes, please
separation.
repeat your answer.
Hi, Jackie, can you hear me?
No, I just want to make
Hello?
sure that you got it all right.
Force directly proportional to product of masses and inversely proportional to square of separation.
Point mass must be there.
Oh,
Gravitational force is directly proportional to product of masses. You got that right. Force between point masses is inversely proportional to the square of their separation.
can I say
What
force
does it
between
mean
the
by point
masses?
mass? Can you remember?
Huh? Uh, yeah, I think it's like
Can the separation must be very much greater than the size of the body, no? That is a point mass, no? Like the Earth and the Moon, they are point mass, no? Because you see You see the diameter of the Earth and diameter of the Moon. You compare it with the separation. Separation is much larger. The idea is you can use this law to simplify your calculation. Okay, binary star consists of star A of mass. That one is a mass 4.0 times 10 to the power 30 kilogram, and a star B of mass 2.0 times 10 to the power 30 kilogram, separated by a distance of 3.3 times 10 to the power 12 meter. The stars are both in circular orbit around the center X, as shown in figure 1.1. This is the second time it came out. Years ago, it came out binary star. So the idea is that distance is completely fixed, and the force of attraction is gravitational force. The radius RB of the star of the orbit of the star B is double RA of the orbit of star A, right? So RB is double that of RA. Use Newton's law of gravitation to calculate the magnitude and gravitational force exerted by each star on the other. So this one is just using the Newton's law
Centripetal.
and put in your value. Right? G is 6.67 times 10 to the power minus 11. Right? Mass of the star A, mass of star B. Okay. Divide by separation. Then use calculator. Calculate the centripetal acceleration. How do you calculate that? Yep.
MV square over R. And then
mv square over r.
oh yeah, sorry.
You already found the force already.
X.
So you have to find the centripetal acceleration of A. F equals to ma.
Oh yeah.
You already calculated that. So acceleration is F divided by m. F already calculated previously. M, there's your M, and get the answer. Use your answer in B part 2 to determine the period of orbit of star A. Remember, they move, it's just like they are attached to each other. And they move together. Okay, they move together. Right, that's what we have given. RA plus RB is this one, and then RB is equals to 2RA. So replace it by 2RA is 3RA. So divide this by 3 to get RA. Then use your centripetal acceleration. Don't worry about negative sign because you want magnitude only. We are not interested in the direction. Omega square x. Omega is A divided by x, square root that. Put in your value of A. Right? A we have calculated that. Put in there. And then RA. Put in value there. Got that. And calculate a period of 2 pi over omega. Okay.
Yeah.
Any comment?
Joe, by the way, which paper is this? Cannot seem to find it in my iPad.
I thought I went over with you earlier there. October,
Okay.
November 2025.
Oh, okay, yeah. Yeah, I'll actually open the other one.
Okay.
Hmm.
This one you just use some of the equation to help you. F is constant. Acceleration is F divided by m. Right? Remember, mass of B is smaller, mass of A is bigger. So centripetal acceleration of B is greater than A. Right? Linear speed is just acceleration times r. So A is greater than centripetal acceleration of B is greater than A. Then R is also greater, so V is greater also. Video is the same for both of them. Yeah, they move as a system, like there's a rod joining them. The rod is gravitational force. Okay,
Okay.
okay, what is P?
Yeah.
Okay, now
Pressure. P is pressure.
pressure of gas, V,
Volume of gas.
volume of gas, and
Number of molecules.
number of molecules of the gas, number of molecules in the gas, K,
Boltzmann constant.
Boltzmann constant, T,
Thermodynamic temperature.
okay, thermodynamic temperature of the gas. Using equation of state, derive an expression for the average kinetic energy of the particle in the gas in terms of sum or all of n, k, and t. What should I do?
Form two equations
What two
of
equation?
PV.
What two equation?
Uh, 1/3 and m means square c square. First one, and then PV equals nkt second one.
Okay, that's the equation. Then the kinetic energy equation. You think that one there? Right, then take a v across there. So these two are the same. Right? N and n can cancel off. Then 3 take across there, you get this one. Then half of this side, half of that side, you get the cancel. Kinetic energy is that one there. It's 3/2 kT. Okay,
Yeah.
molecule of hydrogen gas consists of two hydrogen atoms, each of nucleon number 1. Molecule of oxygen gas consists of two oxygen atoms, each of nucleon number 16, assuming that hydrogen and oxygen both behave as ideal gases. A sample of hydrogen gas is at the same temperature as a sample of oxygen gas. For the two samples, determine the ratio. So have to go to back the equation you have derived. Same temperature, so same kinetic energy. Must be the same for both gases. So get the equation. This one, the root of this one, half and half cancel off. M take it down. Got that one there. T and K are constant. You can use this equation. It's just a lot of calculation involved. That's all. A lot of repeated cancelling. That's all. Right? I prefer to eliminate them. Right? This is root M there. Then for hydrogen goes oxygen. So you want root mean square speed of hydrogen or root mean square of oxygen. That's what you want. So take this one down, square root that. Right? You take the mass, nuclear number, times 1.6 times 10 to the power minus 27. For both of that, cancel off. So you don't have to write down. So it's 4, 10. With reference to kinetic, to molecular kinetic energy and molecular potential energy, explain what is meant by internal energy of an ideal gas. Okay? You want to try?
Uh, total kinetic energy of a gas molecule is equal to internal energy of an ideal gas.
Then, 2 mark,
Because
remember,
the
2 point.
potential energy of ideal gas is 0.
Okay, good. Total kinetic energy associated with random must be there. Random motion of molecules, potential energy of molecule is 0. In state A, temperature of gas is 400 Kelvin. The gas undergoes two successive changes, X and Y. In change X, it is heated at constant volume to a pressure of 4 10 to the power 5 Pascal. At the end of change X, the gas is in D. Right? Can roughly imagine now or draw it on the picture itself. Anyway, you have to draw it later on. Right? That's what it should be. Then in change Y, it is then allowed to expand at constant temperature back to original pressure. At the end of change Y, the gas is in state Z. That's what it should be. Determine the internal energy of the gas at set A. How do I do that? Any idea? How do I do that?
I mean, U equals KE equals 3/2 KT for one molecule only.
Right? They have given you the equation. Internal energy equals to total kinetic energy. Right? 3/2 NKT. So NKT, right? NKT equals PV. PV, and 3/2 P, P, V. Okay,
Yeah.
determine the temperature of gas at state B. Remember, P is proportional to T, as V is constant. The pressure is double, temperature is also double, right? Absolute temperature is also double. Determine the volume of gas at state C. Right? This one is T is constant, PV equals to constant, PB, PB is given, VB is also given. That's your PV. And we use Boyle's law. VC is take a PV down and put in your value. Right? PV, VB, VC. Right? VC is that one there. Original pressure lah. Then calculate out. Can.
Mm.
They ask you to go through the whole process so that you can sketch the graph. Right? Label your lines X and Y respectively. That's how the graph looks like. What are they looking for? Straight line starting from 2 to 4, right? At 0.016. Curve from B, continuous decreasing, negative gradient, label Y. Label Y. And they are interested in starting point here and the end point here. End point must be 0.32. Can
Mm.
X and Y. Any comment?
No.
Oh, okay. This one just to review with you lah. This is the kinetic energy graph of simple harmonic motion. Sorry, kinetic graph of simple harmonic motion. That's so the kinetic energy graph of the oscillation of the oscillator lah. Then you just square the positive one, you get positive. Square the negative one, you get positive also. Okay, state what is meant by frequency of an oscillation of an oscillating object. Yep. Then
Yeah.
what is it?
Uh, 4A.
Number of oscillations per unit time. No? An object is oscillating. Figure 4.1 shows a variation with acceleration A of the object with displacement x from the equivalent position. Figure 4.2 shows the variation of kinetic energy of the object from time t. Explain how 4.2 shows that the period of the oscillation is 0.80 second. You want to try?
Uh,
Basically, you go to zero 2 times, no? Or go to maximum 2 times, no? Right? Kinetic energy object reaches maximum, or minimum, or zero, twice in a cycle.
Kinetic energy twice during one oscillation.
Calculate the angular frequency of the oscillation. So that's why they ask you this question, no? So there is a period, no? Okay.
Yeah.
Apart from period, frequency, angular frequency of the oscillation, determine three other conclusions about the object and its oscillation that may be drawn from 4.1 and 4.2, and the conclusion may be qualitative or quantitative, use the space below or any working. Right, first thing is their oscillations are simple harmonic, no? Then amplitude, maximum acceleration they won't accept lah. Maximum kinetic energy they won't accept lah. But they will accept total energy lah. Right, at 7 lah. 10 to the power minus 4 joule. Right, or any others. Right, these are all the others that they will accept. But make sure you know to calculate, lor. Right? Omega we have already calculated, so they won't accept that. And V naught equals to X naught omega times that, get your maximum speed, lor. That's your maximum speed. Kinetic energy is half mv squared. So m is E, right, from here. Take the 2 across there, take the v squared down, calculate your m, lor. Right, you got 10 more minutes. Right, from m we can calculate the speed, we calculate that, then we can calculate the maximum momentum. Okay, describe the interchange between kinetic and potential energy during the oscillation. Numerical values are not required. You want to try? Kinetic energy is maximum at zero displacement. Potential energy is zero at zero displacement. Kinetic energy plus potential energy equals constant.
At zero displacement is zero. Energy is maximum.
Potential energy is zero.
Yeah.
Kinetic energy is maximum. Okay? These are all
Okay.
alternative answer, except by the marking scheme. Explain why electric potential near an isolated proton is positive. Yep.
Electric potential is zero at infinity.
Okay, that's the first point.
Photon has positive charge. So it will repel each other.
Okay. Force is repulsive, okay. Then
So what must be done on the two positive charges?
you have to do work on to bring them together.
To bring close to each other.
Okay. Work is done on two positive charges to move them towards each other. Right? Or separate them. That's the alternative answer. line XY passes through the center of the sphere. Center of the sphere is that one there. Line P lies on XY. That's P. And the variable displacement X from the center of the sphere. Point Q is a fixed point. Point Q is a fixed position that is not on the line XY. Electric field strength at the surface of here is E naught. On figure 5.1, draw an arrow at point Q to show the direction of the electric field at that point. Okay? Just to guide you, dotted line, and then it should be going away. Okay. This is the marking scheme required. Okay, make sure you know how to plot this point. Right, at the surface R, there's E naught. Right, remember, to the right, if you take it as positive, to the left is negative. Right, electric field is electric field on this side is to the left, on this side is to the right. So that's why it's negative here, positive here. Then they are looking at this point at 2R is a quarter, quarter E naught, quarter E naught, and draw the graph. Yeah, not worry about this point because this point is hard to estimate They are interested in these 2 points 2 points there. Okay, that's how you get a 3 marks. Any comment? Yeah. Proton and electron in hydrogen atom are separated by a distance of 5.3 times 10 to the power minus 11 meter. Calculate the electric potential energy of the proton and the electron given in the equation in the formula sheet. Right, and this is in your data sheet. Q1, Q2. Right, I use this one. Okay, you can use this one if you want to. It's just a little bit more calculation, that's all. And then Q1 and Q2 is the proton and electron. They have the same charge magnitude, square that, separation, right? The distance. Okay.
Okay.
Figure 6.1 shows part of a bridge rectifier circuit that can be used for rectification of alternating input voltage Vin. The circuit contains 4 diodes, one of which is shown. The rectified output voltage Vout is applied across the load. Vout, Vin. State what is meant by rectification. Okay.
Convert AC to DC.
Conversion of AC to DC. State the name of the type of rectification produced by the bridge rectifier circuit.
Should be full wave.
Full wave rectification. And make sure you know how to draw. Right? Just check. Positive. If this pi is positive, cannot go through here. It goes through here, then come back down there. If this pi is positive, it has to go through here, there, back there. Follow the arrow. Right? These two are the same direction. These two are the same direction. Okay. Any comment or anything not clear?
Okay.
Input voltage varies with time, right? That's the equation. Show that the period of the input voltage is 0.35. Right? Compare with your standard equation. No? Right? There is your peak value, omega. No? 18 is your omega. Right? Quote the formula, put omega inside, calculate out, calculate the root mean square. The root mean square, V0 is 34. Okay. That's the reason why they ask you to calculate. No? They want you to draw the graph. You have calculate the period, V0. Okay.
Okay.
They will look at this point. No? That is 0.175. No? And they will look at this point. No? 0.35 second. Okay, anytime will be cut off. Resistor R has a resistor of 56 kilo ohm. Capacitor or capacitance 12 microfarad is connected into the circuit in order to smooth the output voltage. On figure 6.1, draw the capacitor correctly, connect to the circuit. That's how it should be. No? Either this side or that side, same thing. No? Calculate the time constant as the marking scheme. No? Tau equals RC. Yeah, that one. SI unit. That one.